All right, day 15. You guys ready for day 15? I'm ready for day 15. Dueling generators. Here you encounter a pair of dueling generators. The generators called generator A and generator B are trying to agree on a sequence of numbers. However, one of them is malfunctioning, so the sequences don't always match. As they do this, a judge waits for them to generate its next value, compares the lowest 16 bits of both values, keeps track of the number of times those parts of the values match. The generators both work on the same principle to create its next value. The generator will take the previous value produced, multiply it by a factor, then keep the remainder of dividing that resulting product by 214748367. That final remainder's value it produces next. To calculate each generator's first value, it uses a specific starting value as its previous value, as listed in your puzzle input. For instance, suppose its starting values, generator A uses 65, while generator B uses 8921, and the first 5 pairs of generator values are this and that. In binary, these pairs are with generators A's value first in each pair, blah, 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 blah. Here you can see that the lowest 16 bits of the third value match. Because of this match, processing 5 pairs, judge will land 1 to its total. To estimate sample, the judge would like to consider 40 million pairs. The example above, the judge would eventually find a total of 588 pairs that match in their lowest 16 bits. Okay. After 40 million pairs, what is the judge's final count? So, one thing, because I happen to know something about numbers, so what is 2 to the 16th? Is 65536. So when you write a number in binary, basically all the parts up to 65536 are those lowest 15 digits. And so if you mod it by that, that's what you get. So here in the third value, you get 16 bits of that. So rather than turn to binary, if I do, and I might be making a fool of myself now, 65536, and now if I do this other one, mod 65536, they match. And so that's basically saying that the 16 rightmost bits of them match is saying that you get the same result when you mod them by 65536. And so we just want to count how many times that happens. So let's, what do we call this? Generators. Day 15 generators.py. Okay. And so what I'm going to do is I'm going to make a class, and that might be overkill here, but I think it'll make it nice and clean. And I will call this class generator, and it's going to take a couple things in its constructor, and it is going to take a factor, which is going to be an int, and let's say previous value, which is also an int, and we're just going to say self.factor equals factor, self.previous equals previous, and then what we will do is we'll just say what do I want to call this? Let me do a little trick. So I'm going to make this thing callable, and it's going to be an iterator over int, which means that from typing import iterator, and this might end up being a really bad call when it comes to part 2, but I think it will be okay. Import iter tools. Actually, I don't need iter tools. I can just do the following. So while true, what do I want to do? And do I want to use the previous value? I don't want to use the previous value. So what do I want to do? To create its next value, multiply it by next value equals self.factor times self.prev. So multiply the previous value by the factor, and then keep the remainder of dividing that result by this. So let me just mod equals that. So the next value is just this self.mod. So, and then I want to yield the next value, and then self.prev equals next value. So I think that should be what I want. And so let's, generator A uses 65. Sorry, okay. So, generator, oh, I see. So, generator A always gets test A equals a generator where the factor is 16807 and 65, and test B equals generator, and we call it 4821 and 8921. So, you know, for A, B in zip test A, and it's callable, so we can call it test B, and I better use iter tools because I'm using infinite things now. So I want to do iter tools dot look at my iter tools. I want to take the first 5, but I can't remember what the iter tools command for that is. So, which is way to tell Google I only want the Python 3 results. Drop while, compress, star map, take while. All right. Well, here. Let me do the following. Gen A equals test A. Gen B equals test B. For something in range 5, this will be an easy way to take 2. A equals next gen A. B equals next gen B. Print A, B, and then A mod, and then what was the 655536? So let's just check this and see if it works. I think it will. So you can see it's 1092455 430 118 123 blah 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 blah. So these are producing the right things, and it's also producing the right number. So I'm just going to comment these out because I don't really need them. And so if name, and then what do I want? I want to say 40 million pairs. So let me write that function actually. Def count matches gen A, which is an iterator of int, gen B, which is a iterator int, and n, which is an int, and it equals 40 123 123, and that will return an int. So what do I want to do? for something in range n, A equals next gen A, B equals next gen B, and let's just say count equals 0. If A mod 65536 equals B mod 65536, count plus equals 1, and then return count. And now what I want to do is I want to print count matches of gen A and gen B. So let's run that and see if they're telling us that the example above would find 588 pairs. And of course 40 million is a long time, so this is one of those things where it's just going to run for too long. Let me do this. If I mod 100,000 equals 0, print I. That way we'll just we'll get a sense of how fast it's proceeding and if we're going to need to do something else. Okay, so no, this is fine. It basically, if I want to get it to 40 million, then it's just going to have to count up to, you know, it's already at 10 million, right? So we're just going to have to let it run like this for a minute. So in the meantime, I'll just work on the if name equals main part. That way, save some time. So, generator A starts with 289. So really, I maybe should not have made these a class, but whatever. Gen A starts with 289, and I think that was the second one, right? 289, and Gen B equals generator of, and 8921, so 629. 29, and then we want to just print count matches gen A and gen B. So that got 588, and we're supposed to get 588. Good. So now let me just make sure that I have set this up correctly. Generator is going to same factor, and I need to call these now to get the thing. And that might have been a poor design decision. Maybe I should have just given each one a next method, which might have made more sense. Yeah, that probably would have made a lot more sense. Let me just fix that. Next self int. Let me just do this, and then return next value. And we just do gen A, because this calling thing was a little bit silly. Gen A is a generator, and gen B is a, sorry, I probably shouldn't mess with that because it's working. But gen A dot next, gen B dot next. So now let's try this again. And this is dangerous in that I changed the way it worked. But let me, just to make sure it works, let me do just the 5, because I know that that should be 1, and then we can check it out. Good. So that did 1. So I think it's still probably doing the right thing, which is fine. So now just to double check, A is 16807, B is 48271, and then with my values, they're 289 and 629, and 629, and then we can just print the count matches. Okay, I think that's probably pretty good. So let's run it, and again, it's going, 2 million, 3 million, 4 million. So it'll take a little bit. In the meantime, we can try and guess what part B is going to be, or part 2 is going to be, because at this point we're on day 15. We have a good sense for how part 1 goes to part 2. So it's called Dueling Generator, so they're probably not going to add in any extra generators. What they might want to do is they might want to create like a different criteria for when they match, or we might want to count some other quantity, or we might want to 638. So let's try 638 and see what happens. That is the right answer. Good. So part 2. In the interest of trying to align a little better, generators get more picky about the numbers they actually give to the judge. They still generate values in the same way, but now they only hand a value to the judge when it meets their criteria. Generator A looks for values that are multiples of 4. Generator B looks for values that are multiples of 8. Each generator functions completely independently. They both go through values entirely on their own, only occasionally handing an acceptable value to the judge, otherwise working through the same sequence of values where they find one. The judge still waits for each generator to provide it with a value before comparing them, keeps track of the order it sees values, first values, compare the second values. Okay, so this is fine, and so what I'm going to do is I'm going to say as follows. Generator is going to get criteria, or I call it a test, which is a callable int bool. So it's basically, we're going to give it a test, which is a function from an int to a bool, and it is only going to return if this function is true, or if it's none. So self.test equals test, or lambda underscore true. Okay, so if we don't give it a test, the test is just going to be the function that always returns true. And so let's say past test equals false, while not past test. And I'm going a little bit on my way to make this kind of backwards compatible. So that's going to be true. Self.prev equals next value. And then I'm going to say past test equals test of next value. And then once we break out of that while past test, equals self.test next value. Okay, and let me first just make sure that this does the right thing here, and that's going to do 1. And now I want to try something, print A, comma B. Okay, that's good. And now I'm going to say lambda x mod 3 equals 0, and then lambda x mod 5 equals 0. So the first one should only return multiples of 3, the second one should only return multiples of 5. And I don't really know how to tell if things are multiples of 3 or not, but you have to add all the digits. But it looks like it's doing the right thing. And let me change this to 10 and see what happens. So those are all definitely multiples of 10. If I change multiples of 1,000, those are definitely all multiples of 1,000 again, and I'm still getting the same things there. So that seems to be doing the right thing. Okay, so generators willing to consider 5 million pairs. After 5 million pairs, the judge would identify a total of 309 pairs. So, A has to be multiples of 4. So, lambda x mod 4 equals 0. Lambda x mod 8 equals 0. Okay, and is that right? Multiples of 4, multiples of 8. And let me again, and they want to do 1, 2, 3, 1, 2, 3, 5 million. So this is probably going to take another long time, but 309 pairs. So let's run that and see what happens. Whoops, I don't want to print all those. That's way too much. Where did I print it? Okay, good. Yeah, see, that actually is quite a bit slower, but it's not that bad. So we're all to get to 1 million, and we just got to get to 5 million. So let's modify the rest of this. So again, this is, lambda x mod 4 equals 0. B is lambda x mod 8 equals 0. And now we want to count match it, but only up to 1, 2, 3, 1, 2, 3. So I think that's going to be good. And 309 is what we expect. 309 is what we got, so that's good news. And now we can just make sure I did this right. A gets x mod 4 equals 0. B gets x mod 8 equals 0. I get 5 million of them, so I think that's right. Let's run it again. And yeah, it's always a bit iffy to whether you want to go in and add new features to your old code versus just create a new version. Here it seems to be pretty easy to just add this test piece and see what happened. So 36, 37, 38, 39. Yeah, so then this is the really boring part of the video where you have to sit there and just watch for it to run. But it says 343, so let's put in 343 and submit it and see what happens. And that also is the right answer. We're 1 gold star closer, and that means that, tomorrow we can do day 16. Although tomorrow night is Friday night and it's my company's Christmas party, so I will probably not be live coding tomorrow night, but maybe I'll do it on Saturday morning. And if you want to find me on Twitter at Joel Grus, same as usual. And good. This worked out pretty well for us. So thank you for watching. And once again, I came into this saying I'm going to run MyPy and type check my code and make sure it type checks, and I did not. And so let's just for fun. Yeah, it actually does type check today. Okay, cool. Thanks for watching.